Darkness. Not the darkness of night, but the kind born between galaxies. A silence older than stars. A lens of cosmic dust drifts, revealing the pale ember of a distant galaxy. At its center, a heart no larger than our solar system spins matter into oblivion. From that singularity erupts a column of power, narrow as a thought, long as eternity. This is the jet, a filament of plasma launched from the rim of the event horizon, twisted by magnetic fields into a rigid braid. Its particles race outward at 99.9% the speed of light. Invisible to the human eye, yet in radio and X-ray, its glow eclipses whole galaxies. A cosmic lighthouse without a keeper. The camera drifts closer. What looks like a needle is in fact a torrent. Electrons, protons, Ka, and heavy ions accelerated to energies beyond Earth's most powerful machines. Magnetic fields spiraled them into filaments, shaping their course across intergalactic space. They do not slow. They do not fade. They simply go on. Astronomers call this relativistic beaming because the particles move so close to the speed of light. Their radiation focuses forward like the beam of a torch, brightening to whoever lies in its path and dimming to everyone else. If a world drifts across this path, the beam does not swerve. Space is indifferent. Matter simply meets matter, mini-reveal. We live in a galaxy whose heart, Sagittarius A*, is relatively calm. But elsewhere, in M87, in Cygnus A, in distant blazars, jets lance across interstellar darkness for thousands, sometimes millions of light years. Each is born where gravity and magnetism conspire to do the impossible, to fling matter outward from a place where nothing should escape. They are paradoxes, living contradictions, proof of physics still incomplete. Our imaginary Earth drifts onward, its orbit unchanged. Its oceans glint in the sun, but above the sky, beyond the magnetosphere, an invisible tide begins to build. Cosmic rays, billions of them, streaming from a point source. The auroras intensify, spilling equatorial green across the tropics. Airglow shifts. Magnetic lines shudder. Short beat. What would the sky look like? Perhaps nothing at first. Only instruments notice. Geiger counters ticking. Satellites going blind. Then the upper atmosphere begins to fluoresce. A second dawn, ghost pale, unfurling from the zenith. Birds wheel in confusion. Night insects vanish, long drift. Jets carry more than light. They are particle accelerators orders of magnitude beyond the Large Hadron Collider, smashing nuclei together at energies that rewrite atomic bonds. Such cosmic rays have likely shaped Earth's history before triggering cloud formation. Mutating DNA, seeding thunderstorms. But a direct hit from a supermassive black hole's jet would be more than background radiation. It would be a planetary-scale event. Think of it as a wind, not of air, but of near light-speed particles. They ram Earth's magnetosphere, compressing it like a fist squeezing a bubble. Auroras expand. Satellites fail. The ozone layer begins to erode. A rain of muons and gamma rays pours through the upper atmosphere, cascading into secondary showers. Every meter of air becomes a particle detector. Short beat. No shield is perfect. Even the densest atmosphere cannot fully block such energy. At ground level, the dose rises. Electronics glitch. Power grids spark. The human body feels nothing at first, but the DNA within each cell quietly breaks. Long drift. Astronomers once believed jets were harmless, too distant, too diffuse. Yet studies of gamma-ray bursts, microquasars, and active galactic nuclei reveal lethal zones stretching thousands of light years. Within these zones, life as we know it may be impossible. If jets sweep across galactic arms like silent sighs, they may already have pruned entire branches of the cosmic evolutionary tree. Mini-reveal. This is not only a future threat. Some researchers speculate past extinction events on Earth might bear the fingerprint of cosmic radiation, subtle isotopic shifts, sudden mutation spikes, unexplained climate swings. While supernova are usual suspects, a passing jet remains an untested but tantalizing culprit. Evidence, like light, takes time to arrive. The camera pulls back. We see the jet not as a line, but as a living column of plasma. It pulses, knots, and twists with magnetic instabilities. Shock fronts travel outward, compressing particles into flares of X-ray and radio emission. Even now, billions of years after launch, its structure holds. Its origin, a disk of infalling stars and gas, glows like a halo of embers. Short beat. Why does the black hole not simply swallow all it touches? Why this exhalation, this cosmic breath? The paradox deepens. In the act of devouring, it creates. In the act of crushing, it ejects. Long drift. The physics, though modeled, remains incomplete. Magnetohydrodynamics, relativistic jets, reconnection events, each term a technical incantation for processes no human has ever seen firsthand. Laboratories on Earth can simulate fractions of a percent of their energy, but never the whole. Each observation reveals another layer of strangeness, and yet, for all its violence, the jet is elegant, a straightness unbroken across distances where stars drift like dust. If Earth enters this path, the encounter would be less like a collision and more like a baptism into invisible fire. A storm not of weather, but of physics. Rewriting the atmosphere one particle at a time, mini-reveal. Some models suggest that deep oceans might buffer life, allowing microbial survival in abyssal trenches even as the surface burns. Others predict full sterilization, leaving only rock and shadow. Which model is true? The universe offers no answer yet. The scene slows. The Earth rotates under a sky, now haunted by a permanent aurora. Night never fully returns. Day becomes harsh, ultraviolet. Seeds fail to germinate. DNA accumulates scars. Civilization feels the strain in power grids, in lost satellites, in sudden cancers. Short beat. This is not fiction for the cosmos. This is merely another experiment in its laboratory of galaxies. Long drift. From the event horizon to the intergalactic medium. From invisible fields to our trembling atmosphere, the story arcs, like the jet itself, unbroken, unstoppable, indifferent. It is the scale that stuns and the silence. The jet speaks not in thunder, but in particles, in the mathematics of beaming, in the language of space-time itself. The camera tilts upward. We glimpse the galaxy once more, its central heart blazing, its jets symmetric yet skewed by relativity. Across the void, our pale world is only a speck, a target without intent. The needle of fire stretches on, past us, beyond us, into nothing. Somewhere ahead, the beam keeps going. Somewhere behind, the black hole keeps feeding. Between them, Earth drifts, unaware of the mathematics closing in. The jet does not choose, it only moves. And as its invisible spear brushes our fragile sky, the question begins to form: what other worlds has it already erased, and how many more lie waiting in its path? It begins on Earth, not in the heavens. A thin frost settles across a field of metal dishes, each one turning toward a sky invisible to the human eye. Cables hum. The morning air tastes of iron and static. Inside a low building, pens scratch across paper rolls, drawing tremors from the stars. This is the mid-20th century. Optical astronomy still rules, with domes and mirrors and photographs of faint constellations. Radio astronomy is the newcomer, born from wartime radar, awkward and improvised, but powerful enough to hear the inaudible. Every sweep of the sky reveals whispers no telescope has seen before. Invisible lights in a dark ocean. At first, the signals look like noise, stray interference from power lines, car ignitions, or storms. But they persist at the same coordinates night after night. They are steady. They are far. Their power dwarfs any known source. One of these whispers stands out. 3C 273 in Virgo, a dot of radio brightness like a pinprick through the black. In optical photographs, it appears as a pale, star-like speck, unremarkable. Yet on the radio charts, it blazes like a galaxy set on fire. When astronomers widen their view to other wavelengths, the picture deepens. The invisible point sprouts wings, narrow plumes of energy streaming from a core. X-rays, radio waves, even visible light hint at a colossal jet reaching out across interstellar space. Earth's atmosphere shields most of the fury, but cosmic rays and gamma photons still seep through, leaving tracks in detectors. What once seemed harmless becomes something immense. How could a point source be so bright, so far away? The question spreads through observatories from Cambridge to California. Some suspect exotic stars. Others suspect whole galaxies compacted into a single spark. No one yet dares to speak of black holes launching beams of matter in 1963. At Palomar, Martin Schmidt trains a giant telescope on the Enigma. He disperses its light into a spectrum, searching for familiar chemical signatures. The lines are there, but shifted, dragged to longer wavelengths, red-shifted beyond expectation. This is no nearby star. It is billions of light years away, radiating the power of 100 galaxies from a point no larger than our solar system. The term quasar is born, quasi-stellar radio source. Quasars multiply on the charts, each one a lighthouse at the edge of the universe, each one showing evidence of a hidden engine. They vary in brightness over days and weeks, flickering like a heartbeat. They seem to host thin, collimated jets moving at apparent faster-than-light speeds, an illusion born from relativistic motion. Astronomy's map of the cosmos bends, reshaped by forces no one had imagined. In the late 1960s, engineers link radio dishes across continents to form a single virtual telescope. Very long baseline interferometry. Resolution sharpens. The smudges resolve into filaments. Knots appear along the jets, like beads on a string, racing outward at impossible speed. Each new observation confirms that these are not static structures, but living streams of plasma. Guided by magnetic fields and powered by gravity itself, the more scientists learn, the more dangerous the picture becomes. If such a beam ever intersected a world, its radiation could shred atmospheres, seed mutations, destabilize climates. Jets are not mere curiosities. They are cosmic weather systems, capable of sculpting galaxies and sterilizing planets. In mapping them, astronomers are also mapping potential zones of death. Archival footage flickers in the mind's eye. Rows of oscilloscopes. Punch cards fed into computers. Star charts pinned to corkboards, dotted with strange new names. 3C48, 3C273. Cygnus, a generation of scientists, young and old, trying to reconcile a universe far more violent than the one in textbooks. Through it all, the sky remains silent to the human ear. No flashes of visible light, no thunder. Only instruments can reveal the storm. Yet slowly a realization takes hold. Nearly every large galaxy must go through such a phase. Igniting a quasar at its heart, launching jets across intergalactic space. We live in one of the rare, quiet intervals. The narrative lingers on Earth at night. An astronomer steps outside after a long shift, breath misting under the stars. To the naked eye, nothing betrays the cosmic engines he has just measured. But he knows that beyond the soft glitter of constellations, invisible lances of plasma stretch for millions of light years, carving corridors in the dark. Evidence accumulates that these jets are not only visible in radio, but across the entire spectrum. They light up in gamma rays, X-rays, infrared. They accelerate particles to energies far beyond any terrestrial collider. Some may even contribute to the constant drizzle of cosmic rays striking Earth, influencing cloud formation and subtle aspects of climate. The invisible spear touches us already, faint but real dot. By the dawn of the 1970s, the model begins to emerge. At the center of each quasar lies a supermassive black hole. Millions or billions of solar masses surrounded by an accretion disk of infalling matter. Magnetic fields thread this disk, winding like springs. Where those fields tighten, they fling plasma outward in twin beams along the rotational axis. like drill bits boring through space. The more the black hole feeds, the brighter the jet becomes. And still, the paradox stands. A thing from which nothing can escape is also the engine of the most collimated outflows in the universe. Gravity both traps and launches, devours and illuminates. In the act of falling inward, matter is hurled outward. It is a symmetry of opposites, a cosmic exhalation. This realization reshapes our sense of safety. We no longer imagine the galaxy as a serene expanse of stars, but as an ecosystem with predators, storms, and invisible tides. Jets can ignite star formation in some regions and quench it in others. They can bend cosmic filaments, seed magnetic fields, and perhaps dictate the architecture of the universe on the largest scales. They are fingerprints of galactic hearts, and sometimes they're claws. The camera lingers on a radio dish at dusk. Its white bowl tilts toward a sky fading from indigo to black. Somewhere in that darkness is 3C273, still shining after billions of years. Its jet spanning hundreds of thousands of light years, its light only now arriving. The scientist locks the controls, steps away, and the dish continues to listen. A giant ear pressed to the void. The chapter closes with a sense of fragile knowledge. We have charted the invisible sphere, named it, traced its arc. But naming is not taming. Even as our instruments grow sharper, the power behind the jets remains beyond our reach. They remind us that the universe is not built for our comfort or our timelines. It simply is vast and indifferent. And we have only just begun to understand the forces that shape it. In the archives of the sky, the jets keep their counsel. Every chart another fossil of violence light years away. And as the dishes pivot toward the next source, the question lingers: how close must a world drift before it stops being an observer and becomes a casualty of the invisible sphere? A single streak pierces the dark, a line so thin it seems unreal, yet it is born of titanic forces at the heart of a galaxy. At first glance, it is tranquil, like a frozen beam of light. But inside, it is violence. Magnetic storms wound tighter than steel cables and particles hurled faster than anything else in nature. This is a relativistic jet, the aftermath of a black hole's hunger. A cosmic lance that outshines entire galaxies. At its root spins a supermassive black hole, millions or billions of times the sun's mass, surrounded by an accretion disk of gas, dust, and shredded stars. The disk burns hotter than the core of a star, generating intense X-rays and twisting magnetic fields. These fields thread the disk like invisible ropes, coiling with every rotation. When the fields snap or reconfigure, they fling plasma outward along the black hole's poles, launching two opposite beams, twins in perfect symmetry, tearing away from the event horizon at nearly the speed of light. For decades, scientists have tried to map what happens in those first fractions of a light year. One theory, the shock model, imagines slower flows inside the jet colliding with faster bursts, creating shock fronts where particles are accelerated and radiation blooms. Another, The magnetic reconnection model sees the jet as a tapestry of electric and magnetic fields constantly snapping and rejoining, unleashing bursts of energy like solar flares scaled up to cosmic proportions. Neither model fully explains the jet's stability, their brightness, or their astonishing reach. Even with today's telescopes and supercomputers, the heart of the jet remains hidden. If the Large Hadron Collider on Earth is a ring a few kilometers across, a jet is a particle accelerator light-years long. Protons, electrons, and atomic nuclei inside it gain energies far beyond anything human machines can achieve. They spiral around magnetic field lines, emitting synchrotron radiation that spans from radio waves to gamma rays. Observing these signals lets astronomers trace the jet's anatomy. Glowing knots, spirals of polarized light, invisible rivers of cosmic rays. Even light years from the black hole, the jet is still lethal. Its gamma rays can shatter molecular bonds. Its cosmic rays can punch through atmospheres, striking deep into planetary crusts. Earth's magnetosphere, a delicate shield against the sun's wind, would crumple under such an onslaught. If our planet drifted into such a beam, the first sign would be subtle: a shift in auroras, a surge of charged particles. But soon the sky would glow at every latitude, ribbons of green and violet flickering like torn veils. Communications would falter, satellites would die, and the ozone layer would erode, letting ultraviolet radiation from the sun pour through unchecked. The oceans would begin absorbing extraordinary amounts of energy. Water would not boil instantly, but chemical balances would shift, plankton would die, and food chains would collapse. On land, plants would mutate or wither, animals would sicken, and humans would retreat underground. Power grids would buckle under induced currents. Electronics would fail as cosmic rays tore through microchips. The planet would not burn like a fireball. It would be scoured from within by invisible energy. Inside the jet, time behaves differently. Particles near light speed experience time dilation. Their internal clocks slow compared to ours. As Earth passed into the beam, days and nights might blur under disrupted orbits, seasons shifting unpredictably. The atmosphere itself could become a transient particle accelerator, lighting up with secondary showers as cosmic rays strike air molecules, generating muons and neutrons that rain down to the surface. Meanwhile, high above, the jet would continue indifferent to our fate. It would not flicker or pause. It would go on for tens of thousands of light years, shaped only by gravity and magnetism, untouched by the small catastrophe of a single world. From a distance, Earth would become a faintly glowing sphere embedded in a line of fire, its radio transmissions fading as its surface darkened to an observer beyond the galaxy. The event would be invisible, just another planet consumed by chance. Yet up close, it would be a spectacle beyond imagining. Auroras at the equator, nights lit brighter than days, oceans turned to mirrors, continents veiled in strange blue glows. No explosion, no impact, only the relentless pressure of radiation and particles. A storm without wind or sound, astronomers suspect jets can sculpt entire galaxies. They heat and expel gas from galactic cores, shutting down star formation or igniting it in shells far away. The same phenomenon that powers quasars, the brightest beacons in the universe, also sweeps clean the neighborhoods of black holes. What would it do to a fragile biosphere? We have no laboratory to test it, only models and simulations. All agree on one point. Proximity to a jet is not survivable for complex life over long time scales. In imagining Earth inside a relativistic jet, we confront our place in the cosmic order. Our blue world is shielded by thin layers of gas and magnetic fields, a fragile cocoon that seems infinite from within, but is nearly nothing compared to the forces beyond. Black holes and their jets are ancient, indifferent engines. They do not target, they do not spare. They simply are as we study them with radio telescopes, X-ray observatories, and space-based detectors. We learn not only about the jets themselves, but about our own vulnerability. We glimpse the scale of energies at work, the tiny odds of crossing such a path, and yet the certainty that somewhere, sometime, another world has done so. We map these beams across the sky because to understand them is to understand how galaxies live and die, and how easily planets can be erased. If Earth were caught in such a storm, what would remain afterward? Perhaps deep-sea microbes shielded by kilometers of water. Perhaps vaults of DNA drifting through dark caverns. Perhaps nothing at all. The jet would pass, leaving silence and altered skies. Slowly, tectonics would heal the scars, oceans would fill, and life, if any remained, would adapt to a new normal. Millions of years later, a stranger Earth might emerge under a changed sun, bearing no memory of its near erasure. The relativistic storm is both a scientific puzzle and a mirror held up to our own fragility. It shows us how much we still don't know about the universe's most powerful engines. It reminds us that survival here depends on cosmic happenstance as much as on biology or technology. And it leaves us with an image impossible to shake. A planet sliding silently into a river of near-light-speed matter, vanishing under a sky of invisible fire, somewhere far down the beam. Particles continue their flight, unchanged. Somewhere far behind, the black hole feeds, its disk glowing, its fields twisting. And somewhere ahead, perhaps another world already lies in the path, unaware of the storm rushing toward it. How many have fallen into these rivers of invisible fire, and how many more will? The spear moves on. Its light fades, its particles thin, and space becomes quiet again. But Earth is no longer what it was. It still turns, still circles its star, but everything upon it has changed. The oceans glow with a strange metallic sheen. Skies once blue are now pale, thin, and chemically altered. Cities are skeletons, their towers like teeth against the horizon. Across the continents, auroral curtains drift even in daylight. Faint ghosts of the storm that passed. Life, if any remains, has retreated. Some organisms have adapted, burrowing into stone, hiding beneath kilometers of water. clinging to hydrothermal vents. Others have vanished entirely, unable to withstand the invisible knife of cosmic rays and ultraviolet light. If humans survive, they do so underground in carved-out caverns, living by geothermal heat and artificial suns, remembering a sky they can no longer bear to see above. The world bears the signature of a cosmic event indifferent to life. The jet did not choose Earth. It did not aim. It simply crossed our path, a product of magnetism and gravity, older than our species, older than our oceans. Astronomers had calculated the odds, infinitesimal but real. Jets from supermassive black holes are rare, their beams narrow, their lifetime short on galactic timescales. But the galaxy itself is ancient, and planets number in the billions. Given enough time, enough orbits, enough wandering stars, improbable alignments happen. And so, somewhere, some world is always at risk of passing through one of these invisible lances of light pulled back from Earth, and the jet becomes thin. A hairline of radiation stretching into intergalactic dark. The planet is a scar on its edge, a brief flare against cosmic time. Millions of years from now, tectonics will heal the continents, oceans will refill, and the atmosphere will regenerate. The memory of the spear will fade into rock layers and isotopic traces, unreadable to any future intelligence. But in this moment, it defines everything. The odds of survival vary. If the beam was weak, perhaps only the surface burned, leaving deep-sea refuges intact. If it was strong, even the crust may be sterilized. There may be nothing but frozen oceans and scorched rock. Yet life is persistent. On Earth, it endured asteroid impacts, volcanic winters, and mass extinctions. Given even the slimmest chance, it may endure again. But what emerges afterward may be unrecognizable. New species forged in radiation, genomes rewritten by cosmic energy. Ecosystems built for skies of ultraviolet fire. In this reflection lies the essence of the cosmos. For all its beauty, the universe is not built for us. It does not offer safety. It offers possibility. Stars form and die. Galaxies collide. Black holes launch their jets. And somewhere between those events, a thin membrane of life clings to rock and water. Our fragility is not a flaw, but a fact. The cost of existing in a place where gravity bends light and time itself can stretch and tear. We are also reminded of our own ignorance. For most of human history, the sky was a dome of steady stars. Even after discovering black holes, we imagined them as isolated monsters, not as engines shaping entire galaxies. Only with radio telescopes and high-energy detectors did we glimpse their true reach. Jets that stretch for millions of light years, carrying fragments of annihilated stars into intergalactic space. Knowing this, we understand how precarious our position has always been. The camera rises, gliding away from Earth. We see the jet as a thin blue-white filament crossing the darkness, our planet a dim ember at its edge. Farther still, the Milky Way swirls, a spiral of starlight wrapped around a dark heart. Other galaxies float beyond, each with its own core, its own hidden spheres. The scale dwarfs everything, and yet even here, at this vast distance, one question grows heavier. How many worlds has this already happened to? How many civilizations reached for the sky only to be erased by a force they could not see? How many voices were silenced before they could speak across the stars? It is a question without data, without answer. We can only guess. But we know the pattern. Black holes form, accrete, and launch. Jets sweep across space. Planets orbit stars. Sometimes paths cross. Life is a brief, fragile experiment inside a laboratory that does not close its doors. Pull farther back still. The galaxy becomes a pinwheel of dust and light. The jet, once so fearsome, is now a faint hairline on its edge. Beyond it, the universe stretches, clusters, filaments, voids, dark energy flowing between them. In this view, even destruction becomes small, a ripple on an ocean of time. The sphere fades, but its echo remains. It has carved itself into Earth's story and into our imagination. We know now what can happen. We know how easily it can happen. And we know that, if it happened here, it has happened elsewhere. Our telescopes, our eyes pressed to keyholes, trying to glimpse these events before they arrive. To understand forces older and larger than our history, perhaps some future civilization born in Earth's deep caverns will climb back to the surface, find the ruins, and wonder at the strange scars in the rocks and the sky. Perhaps they will build their own telescopes and see the jets. And perhaps they will ask the same question we are asking now. The camera pauses, the galaxy turning slowly. We hear nothing. Only the quiet of space, indifferent and immense. The sphere has moved on, but its shadow lingers. The planet spins beneath a changed sky, carrying the memory of light it could not see. And across the dark, more jets are firing, more worlds drifting, more fragile lives poised on the edge of oblivion. How many worlds have already been erased by these silent lances of light? The question floats unanswered as the universe continues vast, cold, and beautiful beyond measure.